it's a good idea to trying to use something that can produce a large amount of heat to produce electricity. But if you remember, the nuclear fusion condition is really difficult to achieve. Who can achieve like over 10 million degrees Celsius and a extremely high pressure? Okay. Difficult to achieve because of extremely high temperature and pressure. At 10 million degrees Celsius, all substance occurs as plasma. Plasma, I haven't talked about plasma. So plasma is a fourth state of matter where where all atoms, molecules, electron, neutron, proton break apart, and they just they don't have any interaction or no attraction or whatsoever. So plasma is It's explained as a soup of positive and negative charge gas. It's just a soup of like blend of all positively charged and negative charged gas. Actually, so just a neutron and the nucleus floating around. Okay, so proton neutron doesn't dissociate because they really have high binding energy. So just a nucleus and electron. All right. Anyway, so at this temperature, there's no container hold the plasma, even like when everything just melt and become plasma. Right. Well, so just think that if we can't hold it, can we suspend it in midair? And in 1959, Soviet Union successfully made tokamak, which is a magnetic confinement. All the plasma can suspended on midair and never touch the container. Okay, but I mean there's some problem about it, and we have a better one that haven't been used yet. So we call Stellarator. It's the world largest fusion reactor is about to be switched on. So and this the Stellarator is at the Max Planck Institute in Germany. You probably heard the guy Max Planck, which is the web guy. Okay, so he's that famous, right? All right. So anyway, so let's do some concept tests together. Classify each of these characteristics based on whether it applies to fission, fusion, or both. Heavily involved neutrons. Oh, that's fission. That's totally fission. So monotone chain reaction. All right. Used to generate electrical power. That's also nuclear fission. Haven't done it with fusion yet. Results in the emission of radiation. Well, both everything. Well, the fusion produce alpha radiation. Smaller. Larger, heavier nuclei. Fission produce. It could be anything, right? So both requires high temperature at initiation. Of course, this is fusion over 10 million degrees Celsius. Predominates in the interior of the sun. Well, that's only fusion. Okay. Next one. What three conditions must be met for a fusion reaction to occur? Well, extremely high heat, high pressure, and long contact times. Okay. All right. This one more. So, which of the following is our nuclear fission? Well, if you think about it, the nuclear fission, larger nuclei break down to a smaller nuclei, okay? And the one that fall to that category is just plutonium-239, all right, so from here, we're going to talk about the good side of using the nuclear reaction, and we're going to talk about in medicine, okay?